Hi everyone, I'm Kyriakos from TU Delft, and in this demo we are going to showcase Styx, a stateful function as a service runtime that executes serializable transactions across functions with exactly once guarantees. As you might already know, developing stateful cloud applications such as low latency workflows or microservices with strict consistency requirements remains quite challenging for software engineers. Existing approaches either provide serializable transactional guarantees at the level of individual functions or separate application logic from the state and use inefficient transactional protocols. These design choices increase the execution latency, limiting the adoption of stateful function as a service systems. To amend that, Styx employs the following architecture that supports arbitrary function execution with serializable guarantees and revolves around the collocation of state and processing. In this figure, we display how a stateful function workflow gets transformed into a transaction and gets executed within Styx with serializable guarantees and fault tolerance. In this example, let's say that we have a shopping cart that contains items and a user that this cart belongs to. At first, the checkout function gets submitted to Styx via a replayable source such as Apache Kafka and goes through one of Styx partitioned sequencers to get a transaction ID. Then it goes to the function executor where it runs and is also able to call other functions such as the update stock of an item. In this example, the update stock is local and accesses the state directly. On the contrary, the update credit of the user is remote and has to go through a partitioner to reach the worker that contains that user's state and get executed there. Since everything is in memory and we require durability, Styx snapshots are stored within a durable snapshot store. In this demo, we are going to showcase three aspects of Styx: the programmability and how simpler it is to code a microservice architecture on Styx. Through our monitoring UI, observe some key features of Styx like the deployment and rescaling actions and how Styx deals with failures. First, regarding the programmability, we will provide the code of the previous shopping cart example and allow the participants to make changes or write their own code. Here, we can see that the API of Styx revolves around operators that are partitioned and contain some functions like the create order that initializes an order, or the checkout, and how simple it is to code such complex workflows with serializable and fault tolerance guarantees. We currently have deployed the workload on 4 workers. In the UI, we can observe CPU, memory, ingress, and egress network. We also display graphs for the committed transactions per second, the transaction latency, and the current abort rate percentage. We also display the latency breakdown of where the transactional protocol of Styx spends its time. And next are the snapshot latency and the time since the last heartbeat. At around 9:19, we trigger the reconfiguration from 4 partitions to 3, and this appears clearly in all charts, for example, the snapshot latency and the transaction per second. At 9:25, we have killed worker 4, and we notice an increase in transaction latency, but after a while, it stabilizes again. We can also observe that in the time since last heartbeat. We can now go to the worker-specific metrics and take a look on that worker. Here, we can observe that it stopped reporting any traffic. That concludes my presentation. Thank you for your time.